This video is about, in mathematics, what we call relations and functions, all right? So a relation, by definition, is very simply a set of pairs of input and output values. Now, you can regard those input values as x's and the output values as y's, okay? So that's a relation. Anytime that you have two things that are being compared, typically an input and an output, all right, this is known as a relation. There are four different ways to represent a relation. We could represent them as ordered pairs, which is what a lot of you are very used to from pre-algebra or algebra 1, okay? We could look at them as a mapping. A mapping is when we have our input and our output values, and then we draw arrows to match up which input goes with what output. So for example, in this picture here, -3, 4 would be a coordinate point. All right, notice that they're using the same ordered pairs that we had to start off with. Notice how 4, it could be either 4, -1 or 4, 3 for the mapping right there. Another way to do it, some of you guys probably remember doing these before. It's called a T-chart, all right, or just simply a table of values. Again, we have our inputs and an outputs. And the fourth way that we could do this is graphically. All right, we could represent each one of these ordered pairs, each one of these mappings, each one of these table of values as a particular location on a coordinate plane. Okay? Now, we have a bunch of other terminology that you guys need to know. All right? First one, domain. Domain, by definition, is the set of input values in a relation. It is the set of x values in ordered pairs. All right? So domain is x values. Okay? Range would be the set of y values or the set of output values in a relation. Okay? Anytime you hear range, think y values. Now, the way that I keep these straight in my head is I look at domain versus range. I look at the letters that they begin with. Domain comes before range in the alphabet. D comes before R. In the alphabet, X comes before Y. That's how I remember domain goes with X's, range goes with Y's. Okay? Now, this next one is very, very, very important. We're going to be talking about this continually in Algebra 2 and beyond. And that is the idea of what is a function. By definition, a function is a relation, so we're comparing two things, in which each element of the domain, x's, corresponds with exactly one element of the range, y's. All right? Or a quick way to remember this, for each x, there can only be one y. For each x, there can only be one y. For each input, there can only be one output. All right? Now, sometimes what we're going to do is we're going to check this on a graph using something that is called the vertical line test. I also refer to it as the function detector test. My function detector is a straight line, a straight edge that I hold vertically and move from left to right across the figure to determine if, for any particular x value that I show, are there more than one y value. If there's more than one y value, it's not a function. Why? Because remember the definition of a function. For each input, there is only one output. For each x, there is only one y. Okay? We have a function rule, and our function rule is an equation that represents an output in terms of the input. Function rules are written using function notation. Typically, you're going to see something like this, f of x. And what this tells you is the name of the function is f, and in the expression or the equation I use to represent it, I'm going to use the variable x. So you might see something like f of x is equal to 3x plus 2. This is a function f using the variable x, and the actual rule says this, that f of x is 3x plus 2. Now, two other terms that you may see pop up here are independent and dependent variables. All right? Independent variables is a fancy way of us referring to the inputs or x values. And dependent is another way for us to represent the y values or the outputs. Okay? And the way that I remember it, I put down here, it's dependent because it depends on the input to get that desired output. All right? So I know a lot of terminology right there. Please use this as a reference. Go back and look this up. I'm telling you, our first lesson in Algebra 2, you're going to be expected to have an idea of all of these terms, and then we're going to start building on them right away. Okay? All right, so in this first part here, it says determine whether each relation is a function. So we know that we have relations. We know that we have inputs and outputs, or x's and y's, or domains and range. They all mean the same thing. All right? We got to determine, is it a function? So for each x, do we only have one y? For each input, do we only have one output? For each domain value, do we only have one corresponding range value? All right, so if I look at this first one, I've got 3, 5, 6, and 8. All of them go to a unique y value. None of the domain values repeat. Therefore, we can say this is a function. If you take a look at the second example here to the right, one thing that jumps out off the screen to me is this 11 has two different output values. For an input of 11, I could have an output of -2 or an output of 8. For it to be a function, each input can only have one output. Therefore, this is not a function. All right, if you take a look at the third example, again, this one right here has two different outputs. That's simply not a function. All right, if you look at the fourth example, I have a 3, 11, 121, 34, and 23 as my domain values, or as my input, or as my x's. They all mean the same thing. All right, one thing that I notice here is each of the input values is different. Therefore, I know this is going to be a function. For each x, there was only one y. Now, keep this in mind too. Y's can repeat. So in other words, I could have the point 43 and the point 53. That's okay. I could have, again, 43 and 53 where y repeated. That's okay. Because remember, to determine a function, it's for each input, there can only be one output. All right. I like to do this. Hopefully you can see my cursor kind of floating around here. Imagine that my cursor was this long vertical line, all right, going straight up and down. The vertical line test says this: for each input, there can only be one output. If I move this vertical line from left to right, and I get to right here, notice for that input value of x, maybe that would be x is equal to 2. I have two different y values on that particular graph. This tells me for that input, I have two outputs. It's not a function. How about a curve like this one? We'll move your cursor from left to right, that vertical line from left to right. At any point of x, there's only one output value of y. Therefore, we can determine for each input there's only one output. This is a function. Similarly, with this last example, if I move a vertical line across this graph, for each input there was only one output. Therefore, this is a function. Okay? Next thing we're going to talk about is evaluating. Now, evaluate means plug and chug. So I'm going to substitute in a particular value and evaluate it. Now, they gave this to me in function notation. The function is f. They're telling me I'm going to use the variable x, and this 17x plus 3 is my function. 17x plus 3 is what I'm working on. Now, they want me to evaluate it for x is equal to 4. So what they're really asking me to do is to find f of 4. Well, if you notice right here, I simply substituted the 4 in for the x. That's exactly what I need to do on the right side of this function now. 17 times 4 plus 3. What this simplifies to be is how I evaluate the function when x is equal to 4. All right? So if I take 4 times 17, I get 68 plus 3, which would be 71. And I know f of 4 is equal to 71. Okay? Let's try another one here. The function that they give me, f of x, is negative 2x plus 1 over 3. They want me to find f of negative 5. That's what this x equals negative 5 indicates. I go to the function. I have negative 2 times negative 5 plus 1 divided by 3. Notice I moved that negative sign that was in the middle. I moved it up to the top. You don't want it just floating around in the middle. Always give it to the top of the expression. So I'm going to clean this up. I have negative 2 times negative 5 is 10 plus 1 over 3, or this function would evaluate to be 11 thirds. Notice I'm not writing a decimal. I always want to give the exact answer, which is going to be most times with a fraction. A couple more of these to make sure that we get it. All right, here's our function. F of x is 7x minus 9. But instead of leaving the x in there, they want us to evaluate it for f of 3. So this becomes 7 thirds times 3 minus 9. 7 thirds times 3 would be 7 minus 9. And 7 minus 9 is negative 2. I could literally, guys, have written this out. F of 3 is equal to negative 2. That would be a more complete answer. But negative 2 is what you get when you substitute. All right, here's another function. We're going to substitute in 9. So that's saying find f of 9. This would be 2 ninths times 9 minus 9 halves. All right, I know that 2 ninths times 9 would be 2 minus 9 halves. I have a subtraction of a fraction, so I'm going to rewrite this with a common denominator of 2. The 2 over 1 becomes 4 minus 9, which tells me this evaluates to negative 5 over 2. All right, next thing that we want to talk about here is how do I write a function rule to model the cost per month of a long-distance cell phone calling plan. And after I write the function, so notice there's two things to do here. Write a function rule and then evaluate it for the given number of minutes. All right, so my function, this first one, I'm going to call f of x. Now that tells me I have to use the variable x. All right, I know that the monthly service fee is 4.52, and I'm going to add to that 0.12 or 12 cents per minute. I have to use x in there because I name my function as x. We're going to do it a little bit different for the second example. This is my function. Now what they want me to do is evaluate it for f of 250. What does that tell me to do? Take 4.52 plus 0.12 times 250. I'm going to grab my handy dandy calculator here. I don't trust my calculator, so I'm going to type in 0.12 times 250 and then add to that 4.52. All right, I want to tell my calculator the order of operations, and I get $34.52. Okay, let's take a look at the second one here now. All right, this time I'm going to call my function g. Why? Because I felt like it. You can use any letter. You're going to find usually you're going to use like F, G, or H is your names of functions. I'm going to call this one G. And I'm going to use the variable M for minutes. So G of M in this case is going to be a monthly service fee of $3.12. And I'm going to add to that 18 cents per minute. Okay? It's still kind of the same thing that we did before. I just used M and G instead. So now what do we got to find? We got to find G of 175. Notice the M is now being replaced by 175. So this gives me 3.12 plus 0.18 times 175. I'm going to grab my calculator again. I have 18 cents times 175 minutes. All right, plus 3.12, or $3.12, $34.62. 62 cents. Okay. All right, so the last thing that we're going to do here is how do I determine the domain and range from a picture? So remember again, domain represents x's, range represents y's. Now, we're going to identify the domain by using a capital D and the range by using a capital R. If I look at this picture, I know that my x's start here at -4. But wait a minute, what does that arrow mean up above there? That means that it keeps on going out further and further to the left as this graph goes on. All right? So what I know by that is it doesn't have a left boundary. What about on the right side? The right side, it's going to keep going further and further up and right. So the right for us tells me it doesn't have a boundary for that side as well. So we would say that the domain of this is all real numbers. Now, one of the things we're going to learn here is another way to write this would be -infinity to infinity. That's another way to write all real numbers. If you just write all real numbers, that's okay too. Now, the range, though, is limited. If you notice this picture, it does not go below the x-axis. That tells me that the range here is going to be y values that are greater than or equal to 0. Now, what about upward? So it doesn't go lower than 0. Does it go above, or does it, kind of stop or have a ceiling to it? And it doesn't. That's what the arrows are indicating. Therefore, this is my range. All of my outputs in this picture will be y's that are greater than or equal to 0. Okay? How about this one right here now? We've got domain and range. Now, on this one, my x's are limited. They go from where my cursor is over to the other side. Those are the only x's that we have in this picture. All right? So I have a left boundary and a right boundary. I'm going to write this as -3, that's the left boundary, less than or equal to x, and the right boundary, less than or equal to 3. And that represents, 1, 2, 3, yeah, all the x's that could come up. Now, what about the range? Range means I got to start looking vertically, all right, up and down. Well, the low boundary would be -1 is less than or equal to. Range, remember, deals with y's, so I'm going to use the variable y, and it goes all the way up, but it doesn't go above 1. And that would be my domain and range for that particular picture. If you have any questions, please let me know. Good luck.